Hey everyone, my name's Eli Davis, and this is going to be the first video of a series that is aimed at 3D model procedural generation. Um, I've been wanting to do this for a long time, and finally I'm sitting down and doing it. I aim for this series to be you building your own personal library that you know how to work with. I don't care what language you're using, you're going to be able to follow along and in whatever you're comfortable with, being Python or Rust or JavaScript, you're going to be able to understand what I'm doing and go along and build what you need to do, make the tweaks where you see fit because you know your use case better than I know your use case. I'm just here to provide you the tools for you to build with. So, in this series, we're going to be exploring different mathematical concepts, different algorithms for generating meshes and performing operations on said meshes. So, like, how do you cut a mesh or whatnot, or subtract one mesh from another, or do weird chirpy effects with sine and cosine, or I don't know. There's a lot of stuff out there. What inspired me to do this series was the people who have 5-10 years under their belt freaking just blow stuff out of the water. They put out stuff like every day, and it's like, yeah, it's simple to them. You go, oh, blah, 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 blah. And it's like my mind is melting just even looking at what is going on. And like, they're like some god. The other thing that actually finally made me sit down and do this, like I go, okay, today is the day, is I see people or companies make a lot of money doing this type of thing for doing really, really simple things. Like, mind-numbingly, you could work this out on paper in high school, but because they understand a little bit of geometry, getting paid oodles of money, and it hurts. And I know that's just enterprise, but I think I'll sleep better at night if I can teach people the algorithms that they can use to steal money from big business. So, yeah, with that, I'm going to be using Visual Studio's code. You can follow along with whatever. I will be using specific features from Visual Studio's code to make my life a little bit easier. I'm using Golang, but please use whatever you want. And I think with that, I can get started. So in this tutorial specifically, I'm going to start with the basics, and you're going to be able to write models by hand if you need to. You might be able to read certain files with just text, and you'll understand. You can be able to visualize a model in your head. And I'm gonna be focusing on OBJ. OBJ is a great place to start because you can write things by hand, right? It's text. You can debug a file just by looking at it, and it will help us teach some of the more basic concepts like what are vertices, what are faces, orientation, and whatnot. So with that, I'm gonna write a 3D model by hand in a text editor. Nothing special. So to do that first, and for you guys to understand it, I'm going to demonstrate things in the all-powerful tool called Paint. So all three models are composed of triangles, or I should probably more say polygons, but I'm going to keep this a little simple and just say triangles. Just think triangles. So triangles made up of 3 points. In this field, they're called vertices. I don't care if you call them points. I will call them points or dots or whatever. And a triangle can be formed with 3 of these. It's awesome. Well, if I could draw. And so what have I really done here? What am I defining? Is there are 3 points, and we're going to label them now. A, oh wow, that's really small. A, B, and C. So in this file definition, I would have 3 vertices, A, B, and C, and I'd have a single triangle definition, which is a grouping of 3 vertices, A, B, and C. And with that, you have all the knowledge you need to generate your own 3D models. Thanks for watching. But let's go a little further. We can, with this knowledge, really just write OBJ format right away. So if we go into our text editor, we're going to create a test.obj, and we're going to really just write them out. With OBJ, you specify vertices, and it's not comment delimited. It's not a CSV. This is OBJ, so no commas here, or there will be errors. OBJ operates on in 3D, so there's X, Y, and Z components for the purposes of the series. Y is going to be up, X is to the right and left, and Z is forward and backwards. If you have a different opinion, please just keep it an opinion to yourself, I guess. So with this, we will have a point at 0, 0, 0. So what also might be called as the origin. And then we're going to go to the right one. And then we're going to go both to the right and up. So we can then define a face, which is the first vertice, the second vertice, and the third. And that's all there is to it. Notice that OBJ does not start at 0. It starts at 1. So that's just to annoy everyone. Except MATLAB, I think. I'm not sure. Some languages start at 1, but they're not good. We will now should be able to view this file. I have my setup so that whenever I hit test or write out OBJ to the terminal, it's going to open up a certain 3D editor viewer. And then we can see it. So you have a point at 0, 0, and then 1, 0, and then 1, 1. And that's a triangle. That's so freaking cool, right? And like, we didn't have to do any math or anything, and you can read this file and understand what's going on. So great start and all, but we can go a lot further than that. There is one thing I would like to point out though, and this will trip you up depending on the 3D model viewer you are using, especially if you're using a game engine to render things. So in these triangle definitions, there is a concept of orientation. You will need to specify the vertices in a specific order. So notice I did it in ABC and not CBA. So when we're doing ABC, we're going clockwise. And whenever you view points in a clockwise fashion, we know to render them so that we can see it. It would be inefficient if you could look at a triangle in both ways and view it its backside or whatnot, especially in game engines. So, you know, they have to do a lot of stuff to be optimal. And you can look at any Ubisoft game and spend a little bit of time glitched out and see through walls or whatnot. And what's happening is you're viewing the backside of that triangle, and because they're trying to be efficient with rendering triangles, they're not going to be rendering the backside of it. So this won't happen in my 3D viewer, but it might in yours, and I'm letting you know. If you define the triangles backwards, so ACB, it might not show up, and that's just how it is. That's a hack or optimization, whatever you want to call it. That's how rendering works with this kind of stuff. So something to look out for. With that, we can now write some code that will output to OBJ. So we're going to create a mesh struct. It's going to be in package main because I'm lazy. We're going to say type mesh. It's a struct. And really, to create a mesh, we also need the concept of a triangle. So these are going to be the fundamentals. And with that, we are ready, right? So another efficiency we're going to use, and another concept you're going to have to keep in mind, are welded versus unwelded vertices. So really what this triangle is not the vertices themselves, but references to vertices. This triangle says use this one, and use this one. So to be more clear, I'll give another example, which is one step above a triangle, which is a square. Hold up. This is complicated stuff. So our square, you might say, has only 4 points. A, B, C, and D. This would be a welded concept, that there's only 4 points here. And so we have 2 triangles, though. So the definitions of these triangles would be A, B, C, and then C, D, A. Everything's great. Everything's efficient. Will run fast. Optimal memory storage. All that jazz. Some people do not provide you welded vertices, and that's a very easy first step to start to optimize things. So another way this might be stored in memory that would look exactly the same, or generally the same, you would have A, B, C, and then you would have E, F, and D. So instead of this first triangle would be the same, but this next one would actually be different. It would actually be defined as E, F, and D, just to make me rip out hair. So that's something to keep in mind. For the purposes of this tutorial series, I'm going to be trying to keep things welded where it makes sense. There's going to be certain effects that I do later on that I have to unweld things just for the sake of making it look cool. And that's duplicating vertices. And yeah, that's to be expected. Try not to be inefficient, but maybe it doesn't matter in your use case. You know your use case better than me. So I guess do what makes sense. But if you're doing this for something like game engines, do not give me unwelded vertices. Cool. With that information, we can go a little further. If you're using C, you can use pointers galore. I'm not, and I'm also keeping this generic. And also it makes sense once we start writing to file. I'm going to be using indices to an array for my triangle, because my triangle is not going to contain vertices. It's only going to contain references. So we're going to say P1, which is an int, P2, which is an int, and P3, which is also an int. Vertices. It's so freaking cool. Another thing to keep in mind is, as we're doing this, and this is another design consideration to take into account when you're building your mesh library, this triangle by itself means absolutely nothing without the mesh as context. So you can't move triangles around without also moving around the context with them. It will make certain algorithms or things more complicated depending what we're doing. That's the sake of efficiency. That's what happens. So just something to keep in mind. Maybe you don't want to think about all this kind of crap, but that's what it is. I'm here in it with you, so we'll have to think of crap together. Our mesh is going to be composed, like I said, of vertices and triangles. I'm not going to be explaining vector math. If you guys want vector math, I'd be happy to explain it in other tutorials. This tutorial series is not going to focus on vector math. I will be using other libraries to handle this for me. There is vector math libraries for every conceivable language. It's probably one of the first things that happen when a language is created. So don't worry. Just find one you like and stick with it. I'm going to be using a library for vector math. So we're going to define vertices, and it's going to be an array of vectors. And then finally, the triangles. I'll be explicit, and we're gonna say try. And that's really all we need to define things. And so we can actually now go ahead and write our toObj function. So I can say func toObj. I'll be capital because I think that's what Golang likes. I'll say returns an error, and then we're gonna write it to a writer. If you're not using Golang, basically you want whatever primitive makes sense for writing arbitrary bytes out to. So that might be a stream, that might just be a file. Golang uses things called writers. It can represent just about anything. So we could say, please write OBJ to this network request, or write OBJ to this file, or to standard out. It's just a generic way of doing that. Maybe that doesn't fit your use case, and so you know what to put here. I'm just trying to explain to you what I'm doing. So we take a writer, we return an error, and we're gonna now write our contents. So this is a great place to start writing our unit tests. And I have no unit tests, and it's somehow returning green. And that's probably an artifact of me messing up this video 4 times and not restarting Visual Studio's code. But ignore that. For those who don't know, green on a line of code means that the line of code got covered in test coverage. I'm gonna now start creating my tests. So type, package. Package always comes first. For those in other languages like Java or C#, that's basically your package or namespace or whatever. Does TypeScript have namespaces? I think it does. Anyway, somehow to create a collection of code. And we're going to create our first test. We're going to test OBJ. And all tests take a pointer to whatever this thing is. And now we can create our test. So a mesh is composed of vertices and triangles. And our vertices are going to be a simple array. And so I'll explain a little bit about this vector library. I'm going to say vector3.0. That is going to be both the x, y, and z components are all 0. And then I'm going to say vector3 right. And so that is 1 in the x direction, 0 in the y, and 0 in the z. And I'm going to say vector 3 up. And that's going to be 0 in the x, y, 1 in the y, and 0 in the z. And with that, we have our vertices and our triangles. It's going to be really simple. It's going to be one triangle. And it's just going to be referencing the vertices here. Awesome. And then we're going to define our mesh. And it's going to take the vertices and the triangles. And with that, well, we need to create our buffer as well. So we need to write to something when we do our OBJ function. So we're going to create a buffer. And so we're going to call it out. And I'm pretty sure it's bytes.buffer. And so this buffer has a read and write method. It's very simple. You can read and write to it. And finally, we're going to do the thing. Say error is equal to m dot to obj. Weird that things aren't coming up, but that happens sometimes. What is going on without IntelliSense? Okay, so over here, I'm not in my Go module. it's time for me to make a Go module. So we're gonna go say Go mod. And so to those in other languages, I'm basically finally creating my project. I've been writing code willy-nilly, but the tool I'm using is like, what the hell? Where does this code belong to, basically? And I'm going to call this library Mango because I'm drinking a mango beer. And we just say go mod init github.com/Eli C. Davis /mango. Dope. It should do things and make things work again. Hot. All right, mesh undefined. Just because I don't know how to write code. Why would that be defined? Undefined. Oh, wow, I'm really dumb. I'll blame that on the beer. So there, now mesh has that method. Now we're going to assert a few things. And while we're at it, we're gonna say this is the arrange portion. Woo! Up until 80, please. This is something to help me and my little pea brain differentiate what's going on. I hate comments until I don't hate them. Mixed relationship. We will be using a library for assertions. Pick what you want. Asserting things is not something specific to Golang. Unfortunately, there's probably a million different assertion libraries per language. So close your eyes, take a gun, shoot in the dark, and you'll hit one that will give you exactly what you need. We're going to say assert no error. And we're going to pass it the error. And so this should actually... Cool, that's awesome. This should pass, right? We're saying that there's gonna be no error. Wow, that's really cool. You passed. That's amazing. Cool. Now we need to read this buffer. This buffer should contain the OBJ file. So we're gonna say we're gonna have to create a scanner from. Or we don't have to. There's multiple ways to do this. I'm going to create a scanner. Scanners don't make too much sense. If you're in a different language, all I'm doing is creating a way to read from this buffer. I'm going to read line by line. Scanners are a great way of, or generally, I know this exists for Java as well, great way of giving you text that ignores the line break, but gives you the contents of the line. So I'm going to say, create new scanner, and that is going to be from buff.io, and please give me new scanner. And we're also going to pass the buffer. So now we're reading from the buffer we just wrote to. Hell yeah, we have a scanner now. We're going to say scanner.scan, like the Dora swiper. Please swipe these lines from the buffer. Assert equals. And we know the first line here needs to be a vertice. We're going to say 0, 0, 0, 0. And then, so that's what we expect. And what we actually got is what comes from the scanner. Awesome. I have a feeling this is going to fail. Yeah, that failed. Who knew? So we expected this line, but we got nothing. It's probably because we did nothing in our method. So let's do a thing. Let's finish this test. We're gonna go 0, then we're gonna go right, then we're gonna go up. So let's write what we're gonna expect. So we're gonna go right, and then we're gonna go up. And then we're going to write a face out. And it's going to be 1, 2, 3. Perfect. So that should be our file. So let's now make it happen, y'all. We're gonna write a very basic for loop right after taking another drink of our mesh library. So it's gonna be, we're gonna write our vertices first. M dot vertices, and we're gonna start writing it out. So we're gonna say we're actually gonna have to. I'm gonna use Golang's IO to write line by line to this writer. By default, the writer only takes bytes. I don't want to write in bytes. I want to write in strings. So we're gonna say IO dot write string. I'm gonna pass it the writer, and then we're gonna pass it the string. With that, I'm gonna say format dot sprint. If you don't know how to format strings, go look up how to format strings. It's very helpful, very powerful. We're gonna pass it some delimiters. Is delimiter the right word? I honestly don't know. Whatever these cool things are that allow me to format my string nicely. This is another big design decision coming up. So v.x, v.y, v.z. So I'm just saying, right, x, y, and z out to my writer. So why is this a big decision? Well, because I just said I only want the first two decimal places of my float. So this is affecting the precision of my library. For those who need the highest precision, you don't want to limit yourself. I really don't think, at least if you're doing game dev, don't need that high of precision. Y'all knew better than me, but a lot of y'all are impressed by ray tracing in Minecraft. So just think about the pros and cons of what you're doing. Two decimal places is definitely low. I'll bump it up to 5, but that's 5 is overkill. So if you're designing, if you're writing code for a very specific use case, really look into that use case and what you need. Another caveat to that is if you're trying to be efficient with OBJ, you're really just barking up the wrong tree. Use a different file format. So we wrote out our strings, and now we're going to write out our faces. Let's see. You're not gonna autocomplete because you're trash. Dope. T.P1, T.P2, and T.P3. And with that, we have our faces written out. And we no longer need this precision because they're integers. And now we save. And now we realize we forgot to put line breaks in our code. So we're gonna do line break and line break over here. And now what's wrong? Big surprise. I have a lot more zeros than what I expected. In fact, I have 5 more zeros than what I expected. Or what I wrote my test for. So I'm just gonna add all those real quick. I only have to do this for the vertices because my face is an integer. Another thing to keep in mind is some people will write scientific notation out, and that's valid format. It's just something you got to keep in mind. There's going to be sometimes 1e minus 17 or something somewhere. Just be careful. And so I hit save, And I still messed something up because I don't know what I'm doing. Oh, it looks like there's extra spaces. What am I doing? Why do I have extra spaces? Dope. And that looks like it has extra spaces as well. Whoa, that's crazy. Does that work now? Y'all, I'm messing up. I messed up. There's another space. Ah, wow, cool. Cool. I'm being dumb. I needed to start at index of 1. So we're gonna write +1 on all of these. This way, personally, and you guys can make this decision if you want. Personally, I like thinking of index of 0 because I've been slapped enough times to not think that way. So I'm gonna make it so that I can code that way, and then the OBJ exporter will take care of the rest. So that's what I'm doing. Looks like we got 100% test coverage. Pat yourself on the back. That's the highest quality you can ever achieve. Nothing else matters. You can basically call yourself a senior software engineer. I'm going to stop. So we can write to OBJ. That's it. That's great. So what can we do now? Well, we can really honestly start generating 3 meshes. Finally, after I don't know how long I've been talking, we can generate 3D meshes. I'm going to now do such a thing. I think a good way to start is by generating a cylinder or something. Maybe a ring. A ring is, because he cares so much about my life, is the whole reason I started to learn all this is I want to procedurally generate rings so that you can 3D print based on ring size, blah, blah, blah. So that's what we're going to do now. It's going to create a ring. And to create a ring, I'm actually going to have to create a new file. And to those who know Golang, knew this was coming, this is basically the entry point to your program. And Golang, you knew I was going to write one because I made this package to be main. So func main. And it's going to do some things. So really, all I want to do is create a ring. I'm going to say build ring or something. And there's different parameters you can take to the ring. I'm going to stick with 2. Please extend this function to do whatever you want. The more parameters, probably the better. It lends itself to nicer procedural generative qualities and later on. So you think about what you're interested in, and you add those parameters here to tweak the mesh we're generating. So you know what you're interested in. Please go ahead. I'm only going to be doing 2 for the sake of example. So those 2 is going to be the resolution. And by resolution, I mean the number of sides in the circle. You can't make a perfect circle in 3D oh, sorry. With triangles, you cannot make a perfect circle. So, and that's what I've decided to limit us to. Sorry, y'all, is triangles. So there's going to be a resolution. And by resolution, I mean number of sides of the ring. I think generally I use only 32 sides in most cases, but all depends on the use case. So sides, that's going to be an int. And then radius. Actually, let's get a more no, I won't be complicated about it. We'll just do radius, which is going to be a float, 64. And it's going to return us a mesh. Hot. So we're going to build a ring. It's going to take 32, and the radius is going to be, it doesn't matter in this 3D viewer. Yeah, it will kind of. I'll say 2. Whatever. And then we're going to say ring dot to OBJ. And because we use a writer, we can do something cool like os.standard out. So we're going to just write whatever our mesh is to the terminal or whatever. So I'm going to return, what should I do? I'll return an empty mesh because I'm going to set some more stuff up for y'all. So I'm going to return a mesh. Yeah, whatever. Code coverage has gone down because we are trash programmers. We don't know anything about what quality assurance means. We're going to now run our program. Go run. We're going to notice nothing happened. We didn't generate a mesh. Big whoop. But what we can now do is we have our mesh being output to the terminal, even though there's no mesh to be had. But we can use a feature of Visual Studio's code, which is called tasks. Tasks are really cool especially if you have multiple developers working on the same project, working in the same IDE. You can use Visual Studio's code and you guys can start building tasks. One thing we did at work, I have an awesome coworker who made a bunch of tasks that simplifies a really complicated workflow that builds a lot of things and melds them all together. You can get really complicated with this, but I'm going to be doing the most basic of tasks in Visual Studio. So we're going to create a task, whatever. Let's see, we're gonna rerun last task. Run. Can I just not say create? Dude, that's crazy. Whoa. Whatever. Good thing I conveniently have this task at hand. And these tasks go in your VS Code folder. I'm gonna create a new file called task.json. The beer is hitting me. And I'm going to be like every other YouTube tutorial ever and copy and paste code and go, okay, guys, that's it for this tutorial. Thanks for watching. And you know what? It doesn't like comments. If you guys like that comment, please screenshot. It's now gone. I named this task Jen because I can't be bothered to type out the rest of the word for some reason. And I say we're going to run the program. We're going to pipe the output into a file. And then we're going to run the file, which opens up that 3D modeling program. And that's kind of it. Like, holy moly, that's a task for you. Definitely look up more if you're interested in that. But now we can say Control P and then task gen. And you're gonna listen to me. I am the captain. It's not letting me be the captain. Interesting. Weird. Task. I gotta do task. Yeah. Yeah, this is what I meant to do. Yeah. Sure. Whatever. I forgot that I needed to be plural. There's that comment again. Goodbye. And now all of a sudden everything's right with the world. Fire Nation is destroyed. Okay, cool. Now I can run task gen. Y'all, don't do this to me. Task gen. Okay, cool. No need for that. Task gen. Continue without scanning the task output. That's, yep, sure, whatever. And this should open up with nothing, or it will error out with a B. I love seeing the B. The B has actually become a thing in nightmares. Do I get a B today? Yeah, I get the B. Okay, so whenever this program return or receives something that's invalid, and I guess an empty OBJ file, or actually, it's just getting an empty file. It's just like, hey, you gave me nothing. You didn't even give me a codec or anything. Like, I guess here's a B. So that's that. So we'll give it something better than that. Now, that's whenever I run the gen task. Once I have something more valid, I'm going to show you another cool trick with Visual Studio's code. I am sweating beer. If you remember anything from whenever this was taught, you pleb, you would know that sine and cosine make circles. So we're going to make some circles with sine and cosine. To do that, we need to take into account the number of sides we're going to be dealing with. If we want to make a circle, we're going to go back to this drawing board. We're actually going to be making it with a lot of different points. So the more points we make it with, the smaller angular delta there exists for us to go to the next increment. So we got to take into account the number of sides when we're generating this ring. That makes sense since this is a function and sides is a parameter to that function. So we call this variable the angle increment, and it's gonna be 2.0. I don't even know if you need the 0.0 in Golang, or Python, to be honest, but I've become so paranoid. I've been bit so many times by not writing a 0.0 that I just do it now. So this is 2 pi divided by the number of sides. And because sides is an integer, but we're expecting a float, we're going to make this a float. Dope. So this is the delta we're dealing with to go around in a circle. So the higher the number of sides are, the smaller this increment is. So that's a nice way to check yourself. So this function is building a mesh, and the mesh is composed of, dare I say it again, triangles and vertices. And our triangles are tri. I actually called it. And vertices. Dope. And now we can properly return our mesh. Please stop screaming. Please stop. The red underline. I'll be good. So we need to go around in circles. That's kind of life for you, but that's also programming. We're gonna go around in a circle, and to do that, we know how many iterations we're gonna have based on the number of sides that were passed in. We're gonna start at 0. Then we're gonna do the number of sides. And this is your basic for loop. So we're gonna be constructing a ring, and a ring actually has like height or whatever. What would you call it? Yeah, a ring has height. It also has thickness. In real life, a ring is a ring. It's a thick boy. But this is basically what I'm making is a ring. Something you put on your finger. Cool, so we're making this circle. And so we'll see this delta happening. But also, to make the ring, we need these points that go along it. And you need these bottom points that go along it as well. And then these points, they go together. And they make this party hat looking thing. And you can get paid fucking millions of dollars because you understand how to do this. We're going to go around. We're going to go around in a circle. Each delta, I'm not creating one, but I'm creating 2 points to create the height of the ring. So that's what I'm doing. And then once I've created the top and bottom of the ring, it's kind of like sewing. I'm gonna sew these points together with my triangles. I think, yeah, sewing is a great way to think about it. So yeah, let's start creating a ring. If you don't know much about sine and cosine, note to self, I'm gonna go find a good video explaining it. But it's really important for this kind of stuff. Throughout the series, I'll probably be using x as cosine and y as sine. I think that's standard. I don't know what's standard in this. I like doing that. I like seeing x as cosine and y as sine, but I don't know what's standard there. So if you all have a opinion, actually let me know on that one. I'm actually just curious in that sense. So as we go in around a circle, we're going to be passing cosine and sine an angle. What that angle is going to be the angle increment times the current iteration we're on. So it's going to be angle increment times I, and we're going to do float I because that's life. That's the hill I chose to die on. And actually, y is height. I'm actually going to be using sine for the z component because screw everything I just said. I like thinking this is actually important for if you're 3D printing. If you know kind of how your printer operates or whatever. If you're trying to generate a print, you're going to be wanting, you're going to be thinking as you do these programs with your printer nozzle. So it wouldn't make sense to print your ring up like that. That's the worst way to print a ring, I think, on a 3D printer. You want to print it like that, where the ring is able to rest on your bed properly. So that is something important for those who are 3D printing, and maybe others. Who knows? I don't know everything. And then these components, there's the other portion of our function are going to be passed a radius. So now we have an angle that goes between 0 and 2 pi with these sides, and it's going to output a radius. It's going to be multiplied by the radius, so if we make the ring wider, you'll see that happen. Now I'm going to be using a feature of the vector library that I'm using. We're going to say, we're going to be appending to our vertices. I'm not going to redefine them. I'm going to say their vertices, they're going to be v and v dot up. So this is where I need to explain a little, or sorry, v dot add vector dot up. So basically what I'm doing, specifically the vector library I'm using is immutable, so a vector, once it's been initialized, cannot be changed. That makes some kind of like mental headache go away, but is also inefficient. So if you're trying to be as efficient with the calculations that you are using, which I promise you this isn't the bottleneck here, but if it is, don't use this vector library. Don't focus on immutability. I like the immutability because it makes things simpler, easier to explain. But what I'm doing is I'm taking the vector and I'm adding that to our vertices, and then I'm also taking if our vector was added in the y direction. So basically, if I am over here, I've come all the way over here, and now I'm adding a y component to it, so I'm bringing it up some. I'm just raising that point. Awesome. So I'm adding 2 points per iteration of this, and that's going to create us a nice ring. But we cannot do anything with that ring. So if I just run this program, or sorry, go run, you'll see that all we have are vertices, and that is not really helpful at all. But you do notice that each other vertice is raised by 1. So that's great. You can see what's going on. Finally, we need to connect these vertices with triangles. We're going to finish up our sewing. And now you can finally understand what all this explanation's been building up towards, or maybe you don't, and maybe this is all a waste. We're starting at 1. This will make sense later. It makes it easier for me to think about. How about that? And I'll write kind of the program, and then we can talk about it together as a group, because you can respond back. The current vertex is actually multiplied by 2 because we decided to add 2 at a time. So if we're at vertex 1, or sorry, if we're on the first iteration of the sides, which is 1, multiply it by 2, we get to 2. And we know the point right above 2 is 3, and the point to the right of 2 is 4. So we're going to start building out our triangles, and we're going to just keep appending to them, and we're going to create new triangles. Dope. And we're going to say, so we need to build these in a clockwise fashion, right? So we want to avoid being counterclockwise for the sake of game engines. So we're actually going to use the point to the right of the current point, which will be curvert plus 1. Then we're going to use the curvert. And then we're going to do, yep. Curvert minus 1. I think that is it. Now let's get into another cool feature of Visual Studio's code, is you can download extensions to rerun your task as you hit save. I've had it turned off until now, and now I'll show you how to turn it on. We're going to be using some extension that I'll pull up now in the video that I don't feel like finding right now. And we're going to look for task in our settings. Please, for the love of God, do this in a workspace setting, context, extensions. Aha, trigger task on, ... Save. That's exactly what we want. We're going to edit the settings. The task, what is the task going to be named? The task is named Gen, right? That's what I named the task. Yep, right there, Gen. And then we got to tell it what it refreshes on. So we say, given this task, when do we want to run this task? It's whenever we receive a change to the .go file. Dope, cool. I think that's good enough. I will cut to a edit where it is good enough. Control, no. Control P, task gen. Yep, cool. And I don't know how to declare anything. Issue with Golang, okay. Cool, so it ran the task, it reopened up the 3D modeling program. That's pretty cool. I feel like I could like cut something with that, and that's like satisfying enough. But we'll go further for the sake of the video. And let's see if I can stop viewing the property panel. Dope. Dope, dope, dope. Cool. That's a pretty good compromise. So I think if I make changes to this program, it will automatically update. Cross fingers. Cool. Awesome. So now you guys can get like a visual representation what it means to increase the resolution of the triangles. So now if I say 8, measly 8, it's only going to generate one with 7 sides because, if you remember, I started at 1 and not 0. So now I get to explain this for loop, why I started at 1. It's because it's hard to kind of close this loop, ironically, is because you kind of have to be thinking forward and ahead of you. I start at 1 because it's mentally easier for me to think about it. If it's easier for you to think about it starting at 0, I definitely encourage you guys to like look at it and reason about it and come up with a different iteration or a different way for you to do it. That was a great way to learn about how this code works if you're just copy and pasting. I have to now close up this loop of code, so we're going to do that now. So it only requires one final triangle, and that's going from 0 to 1, it looks like. So we're gonna pin one last thing, and if we really think really hard and put our noggins together, we said we're starting at vertice 1. We're building a thing that goes clockwise. So vertice 1, we know, so odd numbers are have been appended the vertex up, so we know 1 is higher than 0 and 3 is higher than 2. So odd numbers are actually, or even numbers are on the bottom and odd numbers on the top. So we're going to start at the top. We're going to go directly beneath us, and then we got to go to the 1 to the left of 1, which is actually ending up on the other side of the loop. So it's gonna be sides times 2 minus 1. I hope to God this works. Hell yeah. Cool. So it looks like we're just about done, except you notice that this isn't looking like something you put on your finger, unless you're like Jigsaw or something. I don't know. So where's the other triangle? We only require one more triangle per iteration, and also a triangle at the end, and we'll have it all stitched up. We'll be about as efficient as we can. Well, I won't even say that. You could be even smarter about this, but this is a pretty easy way to reason about it. Cool. Let's finish this up, and I can get my party on, and y'all can get your $1 million in your pocket. So we know that each iteration is going to require a second triangle. So if we bring out the big guns back over here, we know we just started at, because it's odd, we started up here, then we went down, and then we went back up here. That's what we're looking at right now. So now we kind of want to start here. Or, sorry, actually start here. Where do we want to start? That's a good question. All we have to do is make it clockwise, right? Yeah, let's start up here. And then we're going to move to the right again. And then we're going to move down. And that will be our clockwise function, right? So if this is our current, this is current plus 1, current minus 1, and current minus 2, right? Am I thinking of this right? I feel like I'm thinking of this right. No. Nope, nope, nope. Nope, this is our minus 1. This is minus 2. So it takes, we gotta go through here to get to here. Does this diagram make sense, huh? Does this diagram make sense to you? You gotta be dumb if this doesn't make sense. Come on. Anyway, if you're a man of culture, you would know obviously this is -1. We can keep this the same, and this is -2. This will get us like there. Cool. And now we just got to do that last filling in of the triangle. And we're going to pin one more to it. We're going to kind of keep with the same theme. So whatever, this is -2 because this thing's -2. Yeah, let's keep this 0. And then we'll actually do sides -1 over here. We hit save. And we got ourselves a ring. Guys, we did it. Pat yourself in the back. One of these look weird. Or do all these look weird? I don't know. You can actually view the help. So if we look at the property panel, we can look at the statistics. We can actually see the triangles and our efficient glory, or our near efficient glory. We could get better, maybe in another video. But yeah, you can look at the view, different things. You can see the different things to come with UV sets or whatnot. And I think that's a pretty good thing to stop off on. Actually, I issue y'all a challenge. If you notice that this ring has kind of a missing spot in it, it is right now really just a 2D mesh. It lacks thickness, right? It needs to be thick. So what you'll have to do in order to do that is to create an inner ring. Use your elite hacking skills to bridge the inner ring with the outer ring. And on top of that, you'll need to, not only if you're in a game engine, so extra points if you're a game engine doing this. So you create your outer ring, you create your inner ring. Your inner ring actually has to be facing the opposite direction than your outer ring is. And then you have to bridge it properly. And then with that, everything should be sealed. Please, if you can do that, screenshot it at me on Twitter or something. I would love to see what you guys can do. And then you can take this function and extend it further. Thank you so much for watching. I'm going to shut up now and later.